Alrighty, I'm Lindsay Helverson and I will be doing problem 26. So in this problem, it says a proton moves in the magnetic field B, which is 0.5 Teslas, with a speed of 1.0 times 10 to the 7th meters per second in the direction shown. So we have two parts, A and B, and for each, what is magnetic force on the proton? So for this first one, our V is at a 45-degree angle, and our B is going out in the X direction. So for this problem, we are going to use the equation F, which is what we're trying to find, equals Q, the charge of the proton, V cross B. So for this, we have Q equals 1.6 times 10 to the negative 19th coulombs. Then you have times 1.0 times 10 to the 7th meters per second. And then we need that in both the X direction and the Z direction. So we have cosine of 45 degrees in the X direction, so we have I hat, plus sine of 45 degrees in the Z direction, so we have K hat. And then that's all going to be crossed with our B field, which was 0.50 I hat Teslas. So then when we do this all out, we get F equals 1.6 times 10 to the negative 19th times 0.5 Teslas times 1.0 times 10 to the 7th meters per second over the square root of 2. And then we have, since we crossed I hat and we crossed, so we have I hat cross I hat plus I hat cross K hat, which we know that when you cross I hat and I hat, it just is a 0, so we just have this one that we have to deal with. So then F, your magnetic field, equals 5.7 times 10 to the 13th in the J direction, newtons. Then for our second figure, we have only I hat crossing I hat, and so because our V and our B are both along the X direction, and so this creates our force, our magnetic force to be 0 newtons. And those are our final answers.